means it's a function in which for all values of x the function remains same. For all values of x the function remains same. That is known as simple function. In step function, it depends on the value of x. Function is depends on the value of x. If x is more than 5, then you have to take this as a function 3x minus 1. If x equal to 5, then this is our function 2x plus 3. And if x less than 5, then this is our function 5x plus 2. So here depends on x, we have to select the function. Whereas here in simple function, whatever the value of x, your function remains same. Now let us discuss the example of limit when we have a step function. So this is a step function f of x equal to 5x plus 9 when x is more than 2, 7x plus 1 when x equal to 2, 6x plus 7 when x less than 2. And the question is find limit x tends to 2 f of x. So whenever there is a step function, to find out the limit, you have to find out two limit. One is left hand side limit and other one is the right hand side limit. In right hand side limit, you have to write limit x tends to 2 plus. This 2 plus indicate the value of x tends to 2 plus indicate the value of x is very nearer to 2 but more than 2, like 2.01, 2.000001, but it is more than 2. So if x tends to 2 plus means the value of x is more than 2, and for x more than 2 our function is 5x plus 9. So here you have to write 5x plus 9, and then after you have to put value of x is 2. Actually we have to put x equal to 2.00000001, and if we put 2.00000001 and if we simplify, our answer becomes 19.00000. So 19.0000, that is, you can say that 19. And our left hand side limit, in which you have to write here minus sign. So you have to take a function in which x is less than 2. So x less than 2, that is what? 6x plus 7. So here you have to write 6x plus 7 in left hand side limit. Now here we have to put x equal to 1.999999 like that. So if we put here 1.99999, see, let us check. If we put x equal to 1.999, so if we put here 1.9999, so 6 into 1.999999, let us say like this, plus 7. So what is our answer? 18.99999, and 18.99999 we can easily write is 19. So here left hand side and right hand side both are same. If both the limits are same, then we can say that that is the answer for the limit. So for this question, limit x tends to 2 f of x equal to 19, that is the answer. But if left hand side and right hand side limits are not equal, then we can say that limit does not exist. Then we can say that limit does not exist. Like this question, f of x is given. Now here we have to find out two things. First of all, we have to find out f of 3. So to find out f of 3, what we have to do? We have to put x equal to 3. But in which function we have to put x equal to 3? Then obviously x equal to, when x equal to 3, our function is 2x. In that you have to put x equal to 3. So 2 into 3, so we get 6. So that is f of 3. Now we want to find out limit x tends to 3 f of x. So what we have to do? We have to find out two limit. One is right hand side limit, other one is left hand side limit. In right hand side limit, it's p plus. P plus means more than 3. More than 3 means x square minus 9 upon x minus 3. And now factorize this. So x minus 3, x plus 3 is the factor. Cancel x minus 3 and put x equal to 3 in remaining part. So we get 3 plus 3, 6. And now right hand side, left hand side limit. Left hand side limit means x tends to 3 minus. 3 minus means less than 3. Less than 3 means 5x minus 10 is the function. So in that 5x minus 3, 5x minus 10, put x equal to 3. So we get 5 3s are 15 minus 10, we get 5. Here left hand side and right hand side limits are not equal, so we can say that limit does not exist. So this is the way to find out limit when there is a step function. Why we are discussing this? Because in the chapter continuity we require that particular concept. If any of you have any question, let us discuss that one. If any of you have any question, let us discuss that one regarding the step function and limit for the step function. Any student have any problem? Any of you have any problem? Okay, so now let us start continuity. First of all, definition. Now, see one question: why we have to study this topic continuity? Actually, uh, if you want to study derivative topic, derivative. So in the topic derivative, we require the concept of limit as well as continuity. There are number of uses of this topic derivative, but to get the idea about this topic derivative, we require first of all idea about function, then limit, and then continuity. Because derivative of function is possible only if it is a continuous function. Derivative is also known as tangent, or you can say that slope or tangent. And in tangent, we require to know whether the graph of the function is continuous or not. And to know continuity, whether the function is continuous or not, we require to learn the concept of continuity. That is why we have to study this chapter. Means to get the idea about this big and very useful topic, derivative, we require to know about limit as well as continuity, and that is why we have to study this topic. Okay, there are a lot of uses that we have to study in our next semester regarding derivative. Okay, now let us start. Suppose f of x is a function of x. Now this f of x may be simple function or step function, whatever it is. F of function either simple or step, forget about it. Suppose f of x is a function of x. If the following three conditions are satisfied, then we can say that f of x is a continuous function at x equal to a. A is any constant number like 5, 3, 2, -4, like that. So if three conditions are satisfied, then we can say that f of x is a continuous function at x equal to a. Which three conditions? Condition 1, f of a, means by putting x equal to a, we get something. F of a should be finite. That is the first condition. F of a should be finite. So it should not be like infinite or meaningless. It should be finite. Second, limit x tends to a, f of x should be finite. Limit x tends to a, f of x should be finite. Means in step function, if you want to find out limit, we have to find out two limit. Limit x tends to a plus f of x and limit tends to a minus f of x should be finite as well as equal, because if they are not equal, limit does not exist. So limit of the function should be finite, that is the second condition. And the third condition, the value for both this means a and limit x tends to a f of x should be equal. If these two are equal, then we can say that the function is continuous. Once again, if these three conditions are satisfied, then we can say that function is continuous function. Which three conditions? First, f of a should be finite. Second, limit x tends to a f of x should be finite, and the value of that too should be equal. If any one out of these three conditions is not satisfied, if any one out of these three conditions are not satisfied, then we can say that function is discontinuous at x equal to a. So if we want to check whether function is continuous or not, we have to check one by one all condition. But if any one of the condition is not satisfied, no need to check other condition. Straightforward you can write function is a discontinuous. Okay, so this is the way to check whether the function is continuous or not. See, this is very simple topic, very simple topic. Just by doing the practice of 4 to 5 questions, you will get command on this. So let us start. See, first one. First question is, what is meant by function f of x is continuous at x equal to a? That is a theory, that is nothing but definition. Now this question number 2. Examine whether the function f of x equal to this is continuous at x equal to 2. That is a question. So it is simple function. Why? Because there is nothing like f of x equal to this when x is more than this or less than this or equal to this. Like nothing is given like that. Only simple function is given, 3x square plus 2x minus 1. Only one function is given. So f of x is given here 3x square plus 2x minus 1, and we have to check continuity at x equal to 2. Okay, now we have to check three conditions. First condition, f of 2. We have to find out the value of f of 2. Means we have to put x equal to 2 here. So 3 into 2 square plus 2 into 2 minus 1. 2 square 4. 4 3s are 12 plus 4 minus 1. 15. 15 is a finite value. So we can say that first condition is satisfied. Second condition, limit x tends to 2 f of x means limit x tends to 2 f of x. Now only whatever the value of x, more than 2, less than 2 or anything, this is our function. 3x square plus 2x minus 1. This is our function. So now this is the question of limit. How to find out the answer for this? Just put x equal to 2. If we get 0 by 0, then we have to factorize or we have to do further simplification. Otherwise, whatever we have, that is our answer. So put x equal to 2. So 3 into 2 square plus 2 into 2 minus 1. So obviously our answer is 12 plus 4 minus 1, 15. This is also finite. So my second condition is also satisfied because limit is exist and finite. Therefore, second condition is satisfied. Now third, see the value of first and second. Here 15, here also it is 15. So we can say that from 1 and 2, limit x tends to 2, f of x equal to f of 2 equal to 15. So we can say that both are equal, therefore third condition is satisfied. So we can say that therefore function f of x is continuous at x equal to 2 over. This is the answer. Function is continuous at x equal to 2. So it is continuous function. Let us solve this. Question number 3. Examine the continuity of the function f of x equal to 1 upon x at x equal to 0. Question number 3. F of x equal to 1 upon x at x equal to 0. Let us start first condition. Put x equal to 0. F of 0. So it is 1 upon 0. Can you tell me what is 1 upon 0? Any of you?
Infinite.
Infinite. Perfect. Infinite. That means it is not finite. And because it's not finite, we can say that therefore first condition is not satisfied. Now no need to check any other condition. Therefore f of x is discontinuous at x equal to 0 over. This is the answer. So discontinuous, that is the answer. Now question number 4. Examine the continuity of the function f of x equal to x square minus 6x plus 5 upon x square minus 3x plus 2 at the points x equal to 1, 2 and 5. So we require to check 3 conditions for each of the value, for 1, for 2 and for 5, for each of this. So it is slight lengthy question because we have to check for 3 values. Let us write down first of all f of x only. X square minus 6x plus 5 upon x square minus 3x plus 2. Now let us start for x equal to 1. Let us check for x equal to 1 all the 3 conditions. So first condition, put x equal to 1 in the function. This is also simple function. So put x equal to 1. So if we put 1, what we get? 1 square minus 6 into 1 plus 5 upon 1 square minus 3 into 1 plus 2. So it is 1 minus 6 plus 5 and here 1 minus 3 plus 2. This is 0 and this is 0. Can you tell me what is 0 by 0?
0.
0 by 0
Meaningless.
is not 0. What is 0 by 0?
Undefined.
Undefined term.
Yes, listen carefully. 0 by 0 is not 0. 0 by 0 is not infinite. And obviously 0 by 0, 0, 0 cancel, and if we write 1 then it's very bad thinking. 0 by 0 is undefined. Undefined, that means not finite. It is not defined. So it is not finite. And because it's not finite, we can say that first condition is not satisfied. Therefore, f of x is discontinuous at x equal to 1. No need to check second and third condition because we get the answer. It is discontinuous. So for x equal to 1 it is discontinuous. For x equal to 1 it is discontinuous. Now let us check for 2. So same thing we have to do for x equal to 2. Now for x equal to 2, let us check first condition. So what we have to do, put x equal to 2 in the function. So x square, 2 square minus 6x means 6 into 2 plus 5 upon x square minus 3 into x plus 2. Let us do the calculation. 2 square is 4 minus 12 plus 5. And here 4 minus 6 plus 2. We get here minus 3 and here we get 0. What is minus 3 divided by 0?
Infinite.
Yes, it is infinite. That means not finite. It's infinite. Therefore, first condition is not satisfied. Therefore, f of x is discontinuous at x equal to 2. No need to check second and third condition. But the same thing we have to do for x equal to 5. Now the first condition, put x equal to 5. So what is our function? X square minus 6x plus 5. Put x equal to 5. So it is 5 square minus 6 into 5 plus 5 upon x square means 5 square minus 3x means 3 into 5 plus 2. This is 25 minus 30 plus 5 upon 25 minus 15 plus 2. So here 25 minus 30 minus 5 plus 5 0, and here 10 plus 2 12. What is 0 by 12?
0.
Yeah, 0 by 12 is 0, and 0 is a finite value. Yes, 0 is a finite value. That means first condition is satisfied. Now second condition, what we have to do? We have to find out limit x tends to 5 f of x. But our function remains same. X square minus 6x plus 5 upon x square minus 3x plus 2. Now this is the simple question of limit. This is the question, how to find out the answer of this question. So in limit, what we have to do? We have to put x equal to first of all 5. If we get 0 by 0, then we have to do further step. Otherwise, whatever we have, that is the answer. So let us put x equal to 5. So 5 square minus 6 into 5 plus 5 upon 5 square minus 3 into 5 plus 2. So obviously it is 25 plus minus 30 plus 5 upon 25 minus 15 plus 2. So answer is obviously 0 by 12 means 0, and we know that 0 is a finite value. So we can say that second condition is also satisfied. Okay, now third condition, see the value of first and second both are 0. So we can say that from 1 and 2 limit x tends to 5 f of x and f of 5 both are equal and the value is 0. So we can say that third condition is also satisfied. Therefore, third condition is satisfied. In exam you have to write like this. So therefore, function f of x is continuous at x equal to 5. So it is discontinuous for 1 and 2 but continuous for 5. So it is continuous at 5 but discontinuous at 1 and 2. That is your final answer. But all these three are the question for simple function. These all are simple function. Now let us do one question for continuous. Question number 5. The function f of x is defined as f of x equal to, question number 5, f of x equal to x square minus 4 upon x minus 2. This is we have to use when x less than 2, equal to 4 when x equal to 2, and f of x equal to x plus 2 when x greater than 2. And we want to check, is the function continuous at x equal to 2? So we have to check at x equal to 2, continuity at x equal to 2. Okay, this is the question. Now let us find out the answer. So the first condition, what is the first condition? F of 2. Can you tell me what is f of 2?
4.
Yes, once again.
2 square.
Listen,
4.
listen. When x is 2, what is your function? Once again, yes. Once again. When x is 2, what is
4.
the value of function?
4. 4.
4. Perfect. 4 is a finite number. Therefore, first condition is satisfied. Okay, second condition. Is it simple function or step function?
Step function.
Step function. So you have to find out two limits. Let us find out left hand side limit. You can find out left hand side or right hand side, anyone. We have to find out both the limits. So let us find out first of all left hand side limit. What is left hand side limit? Limit x tends to 2 minus. Now tell me, when x tends to 2 minus, what is your function?
First function x square minus 4 upon x minus 2.
Correct. X square minus 4 upon x minus 2. Now, because it's an example of limit, you have a first step, put x equal to 2. Now see, do the orally. If you put x equal to 2, what we get? 2 square is 4. 4 minus 4, 0. And here 2 minus 2, 0. It is the example of limit and we have a 0 by 0. What we have to do?
Factorize.
Right. Yes, perfect. Let us factorize. The factors are x minus 2, x plus 2. And here x minus 2 is already there. Just cancel this. Now, remaining part, limit x tends to 2 minus x plus 2. Now put x equal to 2. So we get 2 plus 2. That means 4. 4 is also finite. Now right hand side limit. Right hand side limit means limit x tends to 2 plus. 2 plus means more than 2. Tell me, when x is more than 2, what is the value of the function?
X plus 2.
X plus 2.
Correct. X plus 2. And here now put x equal to 2. Actually we have to put more than 2 but nearer to 2, like 2.000000001. So you can put 2.0000001 plus 2. What we get? 4.00000, ultimately we get 4. So it is 2 plus 2, 4 only. So this is also finite. And now because these two are same, we can say that left hand side limit equal to right hand side limit. Left hand side limit equal to right hand side limit. Here left hand side limit equal to right hand side limit. Therefore limit x tends to 2, f of x equal to 4. If they are not equal, then we have to write limit does not exist, and limit does not exist means first condition is not, second condition is not satisfied. But here we have a answer finite value. So we can say that therefore second condition is satisfied. Now third condition. What we have to do in third condition? We have to check the answer of first and second. The answer of first is 4, and here the value of the limit is also 4. So we can say that from 1 and 2, limit x tends to 2, f of x and f of 2 both are equal and their value is 4. So we can say that third condition is also satisfied. Therefore third condition is also satisfied. Therefore f of x is continuous at x equal to 2 over. So this function is continuous function at x equal to 2. Now if we make only one change in the question, like let us say instead of this 4, if it is 5 or any number except 4, any number is given, then let us say 40, then we can say that yes, first condition is satisfied because answer is 40. Second condition is also satisfied. Why second condition is also satisfied? Because the limit is 4, but not equal. That is why we can say that third condition is not satisfied, and ultimately we can say that function is discontinuous if it is anything except 4. So this is the way to solve the example. Now you try for this few questions. Question number 6, that is your homework. Try for that. You can try question number 10. Okay, you can also try this question again. And one more question, question number 23. Try for this, and one more, 17. If you find any problem in this question, we will discuss in our next lecture. This is enough for today. But any of you have any problem, let us discuss that one.